Hello, my name is Mohamad Ikmal Hafiz, and today I'm going to present about the case study on green building and sustainable building. My matrix number is 01DSB18F2029. So first of all, I would like to introduce my building. My building is called the One Angel Square. Okay, the One Angel Square is a landmark in Manchester City, United Kingdoms, with an area of 328,000 square feet. It was built in September of 2012 by 3D Reed Architects with a budget of £110 million. So the reason why I chose this building for my case study is the One Angel Square is one of the most sustainable buildings in Europe. The building achieved the first BREEAM award in the UK. As for sustainability, it is seen as a pioneer in sustainable buildings in Europe. So for my second slide, sustainability in every aspect. So for this building, they use sustainable in construction. Okay, so the architect's vision from the start was to design a sustainable building even from construction. The project used a number of initiatives to minimize fuel and power during construction. Side cabins were heated from dedicated gas. This shows that the architects and engineers resort to a more efficient approach to building, thus saving cost as well as reducing fuel and CO2 emissions. So they use sustainability in construction as in for the workers, for everything. They take into consideration every single part of the construction and to maximize sustainability. So the next point is responsible sourcing. The supply chain for this project is ensured to have high sustainable requirements for a project this scale. For example, early supply chain for M&E, structural steel, precast concrete floors, and two-skin facade ensured robust construction program, minimizing carbon emissions and help the project to reach its strict targets. So for its strict targets, as I said before, it reached the first BREEAM award in UK. So one of the targets was sustainable sourcing, responsible sourcing. Okay, for my third slide is community engagement. So this project also benefits the community. 32 apprentices benefited from the site training. So students get training. The site shop was supplied by a small local business, so it supports the business around the area. Engaged with over 1,000 students in the project, which included support for 2 university projects. So they also support like education in the area. Volunteered over 712 hours on local community projects, raised £21,500 for local charities. So they don't only think about the sustainable side of the building, they also care about the surrounding community. Okay. And then I would like to talk about building description. Okay. The building is future-proof. Adapting to the future climate and global climate projections for 3 emission scenarios: low emission, medium emissions, and high emissions. So they already are thinking about the future environment, the future climate. As we all know, global warming, the temperatures is rising. So it has this decided to focus on 2030 and 2050 time slice for the climate impact assessment. So they assess the project from what will happen in 2030 and 2050 for the building to adapt to that scenario. It has been arranged that the worst scenarios have been selected for this building to assess the climate impact and test robustness of the design against 2030 and 2050's high emission and 90th percentile probability. Okay, as I explained. So this is for my next slide. Analysis for future proofing the building. So this is what they gathered from the study to overcome the future proofing. Okay, to make the building future proof. So based on the climate impact modeling carried out by as observed in the comparison, the following summaries future climatic changes for Manchester. So they summarized that the summers were going to be warmer by increased temperatures up to 4 Celsius in 2050, and as we all know, urban areas are likely to experience more extreme increases due to the urban heat island effect. So this would mean that the cities in Manchester could experience high temperatures of around 31 Celsius by the 2050s, potentially reaching 24 Celsius by the 2080s. Okay, so the current average temperature in the summer is only 20 Celsius. And they also concluded from the analysis that they have milder and wetter winters. So temperature increases in the region, as well. No snow might not be a probability. You might have rain. Temperatures increase in the region that are anticipated to be up to 1 Celsius by the 2020s, 2 Celsius by the 2050s, and 2.5 Celsius by the 2080s. Okay, this is the high emission scenario, so they learn to adapt the building to that scenario. Okay, for my next slide, the building also focused on building orientation for this certain part of the sustainability. The building is south facing, therefore shading devices on the south side of there are more shading devices on the south side of the building. And the building is, as Dad said, the building is also oriented to maximize passive solar gain. So that means the sun rays in the winters or in the cold seasons penetrate the building in the right angles to give it maximum passive solar gain. So for my next slide, I'm going to be talking about the environment surrounding the building. So the 1 Angel Square is built in an urban setting, as I said. Therefore, rising summer temperatures will potentially cause overheating. Overheating occurs when temperatures increase up to a point when it causes discomfort. The effect can be particularly noticeable for occupants when temperatures peak in late afternoon as the building or built environment soaks up the heat from the day. The use of mechanical ventilation and air conditioning is expected to rise in the building due to rising temperatures. This could be worse by, as I said, the urban heat island where the 1 Angel Square is located. Okay, for my next slide, I'm going to be talking about thermal comfort. Okay. First of all, I would like to talk about benefits of double skin facade. Okay. Double skin facade reduce heating demand while controlling solar gain. So it also has thermal properties such as it is insulated. Therefore improving the occupants' comfort level. It is good at regulating the energy cooling and heating loads within the building and the interior spaces of the building. It is therefore saving the long-term cost of maintenance as per energy is concerned in the building. Okay, for my next slide, I would like to talk about air, cooling and heating. So the one in Just Square has a special way of controlling the air cooling and heating in the building. The air cooling is provided via chilled beams utilizing concrete and reducing cooling load for reduced energy consumption. Heating is provided via incoming air through the raised access floor and supplemented with perimeter heating. Okay, there is an active beam system which is very efficient, which is a very efficient way of passing chilled water throughout the building and enabling us to cool the occupants in a very sustainable way. Okay, so that is basically the thermal mass of concrete that is employed again within the building by exposing 300,000 square feet of concrete that forms the ceilings and the floors and office floors. So the concrete acts as a thermal sponge, okay, passively soaking up heat and reducing the amount of energy needed to cool the building. Okay, as you know, that is one of the properties of concrete. To dampen the fluctuations in indoor temperatures as a result of varying internal and solar gains, so to control the temperatures. The thermal mass with a night cooling control strategy helps to reduce the requirement for supplementary cooling, reducing the annual peak and demand. So that also reduces the cost of cooling and maintaining the comfort level of the interior spaces of the building. Okay, for my next slide, I'll talk about ventilation. Summer ventilation. Louvers on the top of the building at top open to allow the warm air trapped between the inner and outer skin to rise up and out of the building. So as you can see from the diagram, there is an atrium in the building, in the middle of the building, and at the top there are louvers to let the trapped air between the inner and outer skins to rise out and escape from the building. So that is a form of passive ventilation. So in the winter, for winter insulation, louvers are closed so the facade can form an insulated blanket around the building. So the facade can be a form of passive comfort, thermal comfort as well.